Hello, everyone. Good day. We're starting our next webinar. Unfortunately, we don't have many participants today, but still a decent number. I think maybe there's one. The reason there aren't many participants is because today's webinar will be a bit challenging as it will be in English. However, we will try to carry it out. Today is November 6, 2024, and the time in Moscow is 4:04 p.m. Today we have a presentation by Edward Lewis from Illinois, United States. Essentially, he will give two presentations in one webinar, as he was unable to present at the conference due to technical reasons. However, today we might be able to listen to it all more comprehensively. The first presentation, essentially, I'm calling it historical, is about what new insights it can bring to our physics, specifically how studying microplasmids might enhance our understanding of linear physics. Into physics. In our physics, linear physics may bring the study of microplasmoids. The second part is about how the characteristics of ball lightning can help us understand the strange radiation. The presentation will be divided into these two sections. Edward Lewis, by the way, seems to have left for some reason. I don't see him right now. Well, I am speaking in Russian, so it is not interesting to him. So he is very, I will say that he took this presentation very seriously, and he confirmed specifically prepared presentations in Russian for us, so we will have them available.
Sorry, I speak in Russian. I wanted to say some words in Russian. Our auditorium better understand Russian. You understand, you know that in English. And after that, I give you floor. But now, 2-3 minutes, I will speak in Russian.
He gave a lot of thought to this webinar and prepared it especially for our audience. Some special types of his presentation in Russian, and I sent it to you 3 hours ago. If you haven't looked at it, I recommend checking it out. Secondly, as far as I understand, Edward Lewis will be specifically moved through these Russian presentations using the slides prepared for the Russian-speaking audience, which is also a huge thank you to him for that. A few words about Lewis. He is relatively new. We have a person who emerged about, a year ago. He appeared at the suggestion of Anatoly Ilyich Nikitin, who has known him for a long time, as I understand it, since they work in the field of ball lightning. And today's presentation really builds an extra bridge between ball lightning and cold fusion, because we all kind of intuitively feel that these are ball lightning is some form of what I call unknown radiation, which most people refer to as strange radiation. Ball lightning is a form of unknown, what I call radiation, but most people refer to it by the term Rudskoy-introduced strange radiation. I would like to remind you that the concept, if Leonid Erbekovich Rudskoy introduced the term strange radiation, it is now more or less understood to be sort of radiation, of course, but it is primarily particles, and we all know that many people they actively working in the field of cold fusion introduce different types of particles or groups of particles to explain the phenomena we observe in our experiments. Edward Lewis will also be talking about some of them today. The idea that ball lightning and strange radiation, and to our audience and to ours, Anatoly Ilyich is here today, I believe. Perhaps Lewis and Nikitin have been discussing this idea within this circle for quite some time. These ideas are also linked with Nikitin's work with Lewis, but today Lewis will share his personal perspective. Edward Lewis will be speaking in English We will ask him questions in English and he will respond in English. I have informed Edward that he needs to speak very concisely and quickly. Please, Bob, speak slowly, shortly, and in very, very simple words. And he just can't, he's such an active person and he immediately starts using very, very complex English. Please speak slowly, briefly, and with very, very simple words. But he just can't, that's how he is. He's so energetic and he immediately starts using very, very complex English. Let's try to overcome the language barrier today somehow. And as for the speech, Bob is laughing because he has a translator there that gives translations with a delay. And that's why Bob understood what I meant. We'll try to overcome the language barrier, and I'll explain this to Edward Lewis, and we should present only after the talks. I suggest that since it's very difficult to present, let's conduct our speeches in Russian, and then Edward Lewis can later present in Russian. By reviewing the recordings, he might consider this in his future work, or possibly even respond to the author's presentations. Friends, I am done, and I hand it over to Edward Lewis.
Please switch on your microphone. This is first. Switch on your microphone. You should. Okay. You find this button.
I found it. Yeah.
Sorry for my more or less long introduction in Russian. I explained for our auditorium that you will talk in English, but I asked you to use simple words, short, simple sentences, and pronounce words very clearly. It's for better understanding. This is first. And second, Ed,
Yeah.
questions to you after presentation, and your answers will be also in English. But discussion will be in Russian, and you may understand what we will talk in discussion after presentation, looking on the video record of our webinar tonight or next day.
Right.
This is my proposal, to mainly in English, but discussion finally in Russian, because for us to use English, it's very difficult to explain what we would like to say. It's absolutely impossible for us to use English. Okay, and I see you succeeded in showing us your presentation. Thank you very much. And
Okay.
I give you floor. Please start your presentation.
All right. Okay. So my presentation. Well, first, Dobre вечер. Is that good? Dobre вечер. So it's okay. So my presentation first is going to be about the history of science. Can you see this very clearly on your side?
I see, but we see, but I explained for auditorium that you will use Russian.
Right.
Russian. Oh, okay. This is next slide. Okay, we see you. Everything is okay.
Everything is
Continue.
okay. Good. All right. So this is my presentation, and this is my website. So if you're interested in my website, it's scientificrevolutions.com. And I have videos I made about 10 years ago with kind of like a interview. You can go there. Okay, so my presentation is about how paradigm shifts in physics causes the Kondratiev wave. But first of all, that there are paradigm shifts. So every 80 years, since the history here. Yeah, every 80 years since Copernicus, approximately every 80 years, as averages to 80 years, there's a paradigm shift in physics. The paradigm shift, so you could read this, started in 1506 here, right? And And this is when the heliocentric theory started. So here you can see there it started from Copernicus, right? To was
It's better.
heliocentric
It's better.
theory,
Yeah.
right?
Mhm.
And then Gilbert, oh, let me see here. Yeah, Gilbert, um, who lived in England, Galileo, Kepler, and then Newton, right? So everybody's aware of this. Newtonian physics was a paradigm. Most people realize that Galileo, around this time, there was another paradigm. Okay, so then there was a Franklin paradigm. It was a paradigm that had to do with fluids.
Just a moment. Just a moment. I asked you to pronounce every words very, very clear. Please take into account the ability Russians to understand English words. Very
Okay,
clear
so
every words, please. Every
yeah,
words.
so yeah,
Try to do that. Try to do that. I know that it's not easy, but try to do that.
okay, so Benjamin Franklin lived in North America in 17, I think he was born in 1705, maybe something like this. Anyway, he started fluid theory. He was the first person to talk about there is a fluid or a matter. He called it matter of heat, matter of electricity. Newton didn't talk about energy in this way. To Franklin, these fluids were conserved. And this was a major achievement that Franklin introduced into physics, that electricity and magnetism are conserved entities, which is a new concept in physics. And so this started here with Lavoisier, Coulomb, and then a man named Aepinus, who developed a theory of magnetism. And then there was Lavoisier developed a theory of chemistry, or it was called fluid caloric chemistry. Then there was an industrial revolution here before the time of Faraday. In 1780, an industrial revolution started based on this theory, based on the theory of heat that Franklin introduced. Um, so James Watt developed a steam engine, and then there was a development of chemical industries here in about 1790. And then starting here, there was a big increase in productivity. Okay, so, and then there was also a crisis period here. Not Faraday, actually, Oersted uh, showed that electricity and magnetism are not separate fluids, but they are the same thing. It was called electromagnetism, right? And Faraday showed or tried to introduce the idea that um, there's an electromagnetic line of force. So he introduced this new concept, and that also that atoms are point atoms. They're not, as Newton and Franklin thought atoms were very hard, small objects, right? Very small, but an object. But Faraday taught they're not objects, they're lines, they're points from where lines of force originate. And so then this allowed Maxwell around 1860, he took this concept and developed a classical field theory. And then there was another crisis period before Einstein where they found many anomalies, right? And so this is my presentation. It's that every 80 years, uh, yeah, every 80 years there's a crisis period that lasts 10 to 20 years. I don't know if anybody in Russia reads The Structure of Scientific Revolutions, but it's a in the West, in the U.S., it's a kind of famous book. If you're interested in science or philosophy of science, we read History of Scientific Revolutions by Thomas Kuhn. So here's that, and you can read that. So okay, so this concept of paradigm shift was originated by him. Oh, what happened here? There it is. Yeah. So wait, let me get up here. I'm having trouble here, so let's see. Ah, I want to go to, try to get up here. This is a long slide. I'm going to have to go very fast, actually. Oh, here. How do I, sorry, I don't know how to use my own software here. Okay, so 11, 10, 9, 8, 80 years, there it is. Okay. So there was a crisis period. Okay. There was another crisis period from 1971 to 1992, and you can see that um, among the people who introduced, um, who introduced some new concepts was actually Deryagan, um, who he was very influential in Russia, actually Soviet Union back in the 1990s, and he one of his students was Andrei Lipson. And Lipson was known in the U.S. because he worked here at the University of Illinois, and I met him. They were working on superconductivity. It's trying to find evidence for superconductivity here, but in code fusion reactions. Okay, so here's so yeah, these okay. So first was Deryagan, and then in the 1980s was Ken Shoulders, right? First Deryagan in the 70s talked about polywater. Ken Shoulders did a lot of research independently and somewhat secretly. He was quite secretive. In 1987, Ken Shoulders wrote a book called EV's The Tale of Discovery, but he kept this book secret. He gave it to very few people. So it was a secret book that I never read until about 5 years ago. Now you can read this book online because people are putting it online. But back then it was a secret book, and so it was interesting. You had to pay about $400 to buy his book. So okay, so yeah, so there's Ken Shoulders, and then there is 1986 superconductivity was discovered. 1989, Fleischmann and Pons and told the world about fusion, about finding transmutation happening in their electrodes. But as everybody knows, and as you know, this field died, right? It basically nobody, after a lot of really controversy, a lot of problems, a lot of I don't know what happened. The field was put down by 1997 in the U.S. It was almost dead. But in Japan, Takaaki Matsumoto here discovered the mission of strange objects. But he didn't know what they were. He wrote an article, and I read about it one morning, where he was talking about, I have found rings on my detector sheets, nuclear emulsions. But he said he didn't know what they were. So as I was reading it, I realized that ball lightning makes rings. I knew this from studying a lot about ball lightning, that sometimes when the ball lightning touches the ground, or if it touches an object, it'll make a ring on the object, a ring trace, we call it, or tract. And so, sorry, I can't read my things here. Yeah, there. So here's an example of the rings. Around 1992, 1991, Matsumoto started finding rings like this. So they were published in Fusion Technology. And so there's 3 rings, and I think many of you, if you've done experiments, may have found rings, but I'm not sure why. One thing I don't understand is Ken Shoulders and Matsumoto usually found rings. They found something like a ring. They didn't find, Russians are usually finding another kind of trace, and I don't know why. So here, um, so um, so there are 3 rings, and right here, there was a hole. And Matsumoto was surprised at this point. I don't know if you can show her. At the 4th point, there's a hole, which suggested to me that the micro ball lightning entered into the plastic. So I wrote Matsumoto and told him about this idea that he's making ball lightning. So he started to do ball lightning research. And he started to attend ball lightning conferences, because his papers about micro ball lightning were not accepted by other people. So he couldn't present at the international ICCFs. So he started to present in ball lightning conferences. And so here's a, so yeah, basically I think the reason there's these 80-year periods in physics is because there are 3 steps, 3 generations are required for one theory. First, there's someone has to develop the theory. So, for example, Einstein. Someone has to initially conceptualize the theory. For example, Einstein, right? And somebody has to then develop the theory. So, in the 1930s, 1940s, there was a lot of development of quantum mechanics theory, right? And also the development of relativity theory with theories about black holes around that time. And then there was another crisis period in the 80s and 90s with a lot of experimenters, including Matsumoto and Ken Shoulders. But then, yeah, so it takes 3 generations to develop a theory. And then you can read this. I tried to show how each of these paradigms kind of developed, like that. So because it takes 3 generations, these 3 generations usually do their work within 80 years. And so the first stage is done in 40 years for development. The second stage requires about 10 to 20 years, but it requires the experimenters to reach middle-aged. So all these researchers, Fleischmann and Pons, Derryagin, Matsumoto, they were all in the middle age, like older than 40 when they were doing their experiments. And because it takes maybe 40 years for people to gain education and then to have some training and then to develop their equipment, right? So it takes, by the time they're middle age, they can start to discover anomalies. So Davy discovered that there are heat anomalies, which led to the theory that atoms, when they vibrate, that heat is a vibration of atoms and molecules. That idea came from Davy, and yeah, so that replaced fluids, the idea that heat is a fluid. Faraday introduced line of force theory, which replaced the electrical fluid. And then Einstein started to teach that energy is quantized, right? That there's a quanta of energy. So there it goes. Yeah, energy is quantized. And then when Matsumoto started to produce ring traces that were 80 micrometers wide or 50 micrometers wide, and other kinds of tracks, like I used to call them like ditches in the plastic, or ditches in the electrodes. They'll find like grooves, like scratches, right? So they make those markings, and I realized he was making ball lightning. So I told this idea to Ken Shoulders also. I wrote him a letter, and he got interested in Matsumoto's work that way. And Matsumoto got interested in Ken Shoulders' work because I sent Matsumoto wanted copies of Ken Shoulders' patents, because Ken Shoulders had patents on his devices. So I sent him copies, photocopies of that. Okay, so I don't know if you can read this, but what does it say? Yeah, but there's not been much research. Okay, so back in the 1990s, maybe 5 or 6 people were doing experimental research on microplasmoids, Ken Shoulders, Matsumoto, and I found them in George Miley's experiments. When I was working with George Miley, I found tracks and markings of ball lightning, but there were very few people. But then, let's see here. Oh, okay, so part of this presentation is about the cause of the Kondratiev wave. So Nikolai Kondratiev was a Russian researcher who lived in the 1920s, 1930s. He introduced the theory that every 50 years, on average, there is a economic depression in the West. And also, so there's an economic cycle. this economic cycle, it continues to now. And so there's two kinds of depressions. One paradigm shift in physics causes two kinds of depressions. The first depression happens during the Industrial Revolution. They're called Industrial Revolution depressions. So IRD. So I call them IRD. Industrial Revolution depressions happen during the Industrial Revolutions because the old industries die away, and the new industries are very small. And even though they're highly innovative, for example, in the 1970s and 1980s, there was a lot of innovation of computer technology, semiconductors, lasers, and all these different kinds of things, right? And that led to telecommunications, but that we're using now. Like even this computer these concepts were developed in the 1970s and 1980s during the Industrial Revolution. I'm sorry, I'm talking too fast. But okay, so there was that was one kind of industrial revolution. And then 30 years after, when the industries begin to develop and mature, there's a great surge of productivity, a great labor productivity increase. And so this labor productivity increase causes people to be unemployed because machinery, automation, replaces the human labor. And so when people cannot work, they cannot have the money to pay for their houses or pay for food or anything or something like that. So then there's a depression, another kind of depression starts, like it happened in the 1930s. So you can see the two kinds of depressions here. The IRD and the technological acceleration depressions and the industrial revolution depressions. We just went through technological acceleration depression that started in 2008. But because of the American economy, because the US government can print trillions and trillions of dollars, and because everybody was using the American currency, right? Everybody was using the American dollar. So no matter what the American government did, no matter if they make 30 trillion or 40 trillion dollars, because so many people use it, so many billions of people use the dollar, they can somehow pay for everything in the US is being paid for, much of it is being paid for simply by borrowing money. And so there's major problems with too much debt. So okay, so here are some anomalies. Takaaki Matsumoto found these anomalies, and then you can read that. And so here's a chart I made where I showed the two different kinds of depressions, right? The technological acceleration depressions are here, here, and here. 1815, 1950, and we're still in this area. Technological acceleration right here. Oh, no, 1830, yeah, 1830, 1930s, and now we're still in this area in 2020s of a depression era. And then there's, let's see. Okay, so now there's a super high debt in the US. Oh, here, I'll try to show you a chart. So yeah, the national debt is $3 trillion, which is a lot of money. And then the total debt is about $37 trillion. And every year now, the debt is increasing by $3 to $4 trillion. So this is how the American economy operates. We operate, the government makes money, the government gives the money to people, and most Americans are on some kind of government aid. We get aid for food, aid for our medical care, direct money is given to our bank accounts, all this. So, okay. And then money is given to industry to operate, money is given to the government to operate. So here's okay, so here's the interest of the national debt and how it's increasing. So the reason there isn't a world depression right now is because of so much American money, and not just American money, but also in Europe and in Asia, everybody is just having all the governments are being operated on debt, and so here's the interest rate increase. So in the last 5 years, it's doubled. So now the American government has to pay more than $1 trillion as interest payment every year. So yeah, we're in a depression area. So I think I came to the end of this. What time is it here? Probably this is not, I don't know if there's any economists watching us right now. I published an article in a Russian journal about 2 years ago called Social Studies. I mean, it's called The Long Waves. So you can look it up. There's a Russian journal that published a long article about this. And another article was I showed this was published in an American magazine. Yeah, this one, journal.cycles.org, issue this one. You can find this online, and you can find the other one online too, or you can find it through my website. So yeah, mainly I just wanted to say that right now we're in a time in physics where because of so much opposition and not enough people studying microplasmoids, there's not much evidence. So over the last 30 years, I started researching in 1992. There's a lot of research, very good research by Ken Shoulders and Matsumoto. Then they died, right? They got old and they retired and died. Then the Russians started to do the research, but they replicated much of what Matsumoto and Ken Shoulders did. And then they actually introduced some new things. Like, for example, for some reason, I call them zigzag or caterpillar traces are very common in Russian research. And Ken Shoulders also saw those, but he usually found rings. Like in my next presentation, I'll show what kind of rings that Ken Shoulders usually found. And I'm wondering, why is there a difference? It could be that Ken Shoulders' equipment basically, for some reason usually produce that kind of a mark. And when Russians do it, maybe for some reason your configuration of equipment is making more of these zigzag tracks. And so I don't understand why. But I do think it's the same thing. I don't think what Russians call strange radiation is different than what Matsumoto and Ken Shoulders studied. But this ball lightning is a very, very amazing and really astounding kind of thing. It has so many shapes, and it's so many configurations of, like, for example, when they make groups, they can make like rings, or they can make all kinds of geometrical shapes, or they make sometimes they just form a chain, like a straight chain, and you can see chain flying through the air. Um, so I've seen ball lightning about 3 times in my life, and okay, so yeah, but basically, except for these observations and except for some research that Russians are doing that is very interesting but needs to be replicated. There has to be replication for me to understand what's happening more clearly. And people have to write good scientific articles. But in our field, there's much secrecy. Usually, for example, right now, Lutz Geithner is doing experiments in Europe, but they don't talk about it. You can't find any article about their experiments. They're keeping it secret for some reason. And a lot of times, maybe this is due to they want to have a patent, right? So as long as people are doing secret experiments and are not publishing good articles, it's hard for me to know what's going on because I need to see that the same thing is replicated by other people to know if something is a fact. If something is a fact, then you can like start to develop the theory of these plasmoids. But right now, we know they exist, we know how they behave. You can conceptualize them as electricity or something like this, or people have tried to say, yeah, there are different configurations of how ions and electrons and everything configure themselves to make these plasmoids. But this is all speculation until much more experimentation is done. But we live in a world where maybe there's about maybe 10 groups of people doing research right now on these, experimental research. And it's simply not enough evidence, I think. During during the 1930s, 1920s, quantum mechanics was accepted by everybody. It became the standard paradigm in physics. But now, this little paradigm of plasmoids is just almost unknown to the world. So we don't have enough money and enough equipment to study these and in the way they need to be studied to understand them. Because it'd be good to understand what their effect of plasmoids is on gravity or is on time, because there is some kind of connection because of gravitational effects that people have seen with very, very big ball lightning and very, very big tornadoes. There's gravitational effects. I mean, people feel like they're being raised or drawn, but it's like some kind of force is picking them up. And so, yeah, but all this stuff needs to be researched, and so that's my yeah. So it may be if this field can continue to develop, uh, maybe yeah, young people would be interested. It has to be young people interested, because only young people have minds and that are fresh enough and to be able to make new theory. In the history of science, it's usually young people who make the new theories and who develop each paradigm. And but the problem in America is no young people know anything about ball lightning. It's a field that nobody. I know this because I talk to graduate students and undergrads in physics. They don't know anything about what I'm talking about, and so this field is pretty much operating at like, I don't know. It's a very strange field to be in right now. Okay, and then maybe if the field can develop more by the 1860s, there could be a start of another industrial revolution based on ball lightning and plasmoids and what we're working on, transmutation devices, right? But it hasn't happened. So okay, so that's the first presentation, and I'm going to show you my next one now.
Okay, Edward.
Yeah.
Let's make some interruption. Maybe somebody Russians would like to put some questions on that part of your presentation. And
Okay.
now I wanted to ask for my auditorium in Russian. Just a moment. Friends, he finished the first part. It's 5 minutes, a bit more, almost 50 minutes. Maybe someone has some questions. Try to ask them in English. To get started, you can first raise your hand if someone wants to ask. You can raise your hands to begin. I'll ask one question. I see Anatoly Klimov raised his hand, but first I'll ask two questions, and then maybe someone else aside from you will want to ask something. Ed, two persons would like to put your questions. First, me, and the second, Anatoly Klimov. And I ask you, I have two questions. First question, idea, it's for me personally, the question is, for me personally, the idea of three generation to solve some scientific problems, to change scientific paradigm into industrial revolution. It's a relatively new idea from my viewpoint. And the question is it your personal idea, or you have see some idea in some discussion or in some literature? This is first.
Yeah, yeah. It's actually, yeah, it's my personal idea. I think I think Jesus Christ actually gave me this idea because I prayed a lot. Back in the 1980s, I was trying to understand why are there Kondratiev waves, and then this idea, yeah, the idea that every 80 years there is a paradigm shift is a new idea. Yeah, from the
Okay,
19,
you gave your answer. Thank you.
yeah.
My friends, I asked, just for the Russian audience, I'll say, I asked whether this idea of 3 generations for a scientific paradigm shift and the scientific and technological revolution to happen was Edward's personal idea, or if he had seen it somewhere else and just developed it in our report. He says it's his own idea. That's very interesting. I think it's very important and seems quite true. And now I'm going to ask him a second question. Ed, and my second and last question. Fifth meta statement is it your idea, and what year you born this idea?
Yeah, it's my idea also. So in 1992, I realized, yeah, I mean, like, actually, I give the glory to God. I think God gave me this idea of micro ball lightning because nobody believed in that. And then when I thought about it a lot in 1992, I started to realize how small can ball lightning be? I was thinking, okay, if they're 50 micrometers wide, 1 micrometer wide, can they be much smaller? Can they just be the size of one atom, right? And then I started to realize in early 1990s, yeah, that there's another kind of matter that atoms, the regular atoms like solid and plasma, like that, those kinds of atoms can convert to this other state of fifth state. Yeah, so that's my idea too.
Okay, thanks. Friends, I am translating what I asked and how I understood his answer. I asked this 5th state of matter he talked about today. Is it, he said it's his idea and it came to him in 1992. Essentially, this idea of the 5th state of matter, apart from the other, besides the 4 states known in physics, the 4th being plasma, he refers to the 5th state of matter as related to plasma, to ball lightning and plasmoids. In 1992, he started. This idea has been explored for quite a while. In fact, 32 years ago. Okay, Ed, I give the floor to Anatoly Klimov. Tolia, your question, please.
Thank you, Edward. Very important for me to meet you in our workshop, our webinar. I see you the first time. And my question concerning, continue the question of the Valery Zatilepin concerning to the 5th state of matter. The first who give the name plasmoid was Bostic. Do you know?
Right, right.
But he believed that magnetic field, magnetic forces inside of this plasmoid is comparatively strong compared to the Coulomb forces. Magnetic field, magnetic forces very important for the structure of the plasmoid. Bostic believed in this hypothesis, but what the main idea to use this name from yourself, from you? It's my first question.
Edward, please answer on first question.
Anatoly Klimov is right that Winston Bostick pioneered this field of plasmoids in the 1950s, 60s, 70s. In 1970s, he started to work with Nardi, yeah, and and his theory, because I've read his theoretical papers was about magnetic fields, and I think Anatoly was asking me, why do I use this word? Because I use the word because the only other word I can use is ball lightning, but ball lightning is too long, and I mean, and it's also ball lightning is only one type of this kind of plasmoid material. Because ball lightning is what we see in the sky, right? When people say ball lightning, they're talking about an atmospheric ball lightning. They're not talking about microscopic objects that are inside of other materials. So, yeah, so I just use the word plasmoid because it's a very, very good name. It just, you have to redefine, instead of thinking about instead of trying to theorize about the structure of a plasmoid as held together by magnetic fields, the way Winston Bostick understood it. Uh, Basically, you have to just the way I understand a plasmoid. It's I never really think about it. Plasmoid is contained by a magnetic field. Ken Shoulders, who continued this research from Winston Bostick. If you read Ken Shoulders' book, and you can find his book online, he talks about how he knew Winston Bostick. He knew other people. He was quite active in physics in the 1970s and 1980s. So his idea is somehow electrons clump together, but he didn't know how. So my ideas, I guess, are kind of closer to that. I don't know how. I really we don't really understand the structure of a microplasmoid or a ball lightning. We don't understand this fifth state, even though many people have, not many, a group of people have tried to understand it. I still think there is not enough evidence. We can't examine the inner structure of a microplasmoid yet. And until we can do this, all we can do is make them most of the time. And then we find there's markings, and then we find there's transportation caused by these little micro ball lightning, but we don't know, we really don't know much about this state. So yeah, I'm sorry I took too long to understand. Yeah.
Okay,
Oh, yeah,
Edward.
Ed, may I ask you to use 2-3 minutes for answer? Oh, no, not very.
Okay. Sorry.
Because time very no, we have limited time. So yeah, please translate your question for our audience into Russian and add a comment to your question and its answer.
I asked Edward what he means by the term plasmoid and how his concept of a plasmoid relates to ball lightning. The first person to give it an actual name was the American scientist Bostick. Well, I understood from his answer that although he liked this name, it should have been called micro ball lightning. It is a great name, but he called it plasmoid. It is a beautiful word. He has no connection with Bostick. My second question concerning to the another very key person in the Russia, it's Nobel Prize winner Piotr Kapitsa. Do you know Piotr Kapitsa, Edward?
Yeah, Kapitsa. Yeah, and so
Kapitsa,
yeah.
Kapitsa.
I'd say Kapitsa.
And he was the second scientist who used this word, this name, plasmoid.
This term.
But comparing with the Matsumoto, it's he used electrodeless, without electrode. Discharge created a high frequency microwave plasmoid, And so this very interesting interaction of the plasmoid with materials, different materials, is typical for the electrical discharge with the electrode system. It's a trace of the cathode drop, cathode dot in the surface of the cathode or anode.
Mhm.
And so, what's the difference? Do you differ? Can you explain the difference between the Matsumoto approach and Kapitsa approach? Absolutely different approaches.
Yeah,
Plasmoid the same.
right. The plasmoids are, it's very, it's confusing. I know what you mean. Okay, I've read very little about Kapitsa. That's how, I mean, I knew that he did nuclear research, right, in Russia. And I know that he studied plasmoids, but I am not really aware of the kinds of tracks and markings he made. So if you could send me, or if I could find some like an article that shows these pictures of what kind of markings he made. The difference here, okay, here in America, if you watch YouTube, there's people making microwave. They use a microwave oven, you know, like these little microwave ovens to make plasmoids. But it seems to me that these plasmoids are different. So I think in nature, there's another kind of object that's it's not in the fifth state. It's more like a plasma that is contained, but somehow self-contained. But they're not a fifth state of matter because you can't find transmutation. Klimov, did Kapitsa ever announce that he found transmutation when he did the experiments?
Yes, he has a transmutation from the deuterium to the helium.
Okay. But not from not palladium to silver to
No,
gold.
no, not at all. It's electrodeless discharge,
Right.
microwave discharge. It's without electrode.
Yeah, I understand. It's similar to Winston Bostick was also doing research on making deuterium to helium or something like this, but using electrical discharge. But it doesn't seem to be the same thing to me. It's I believe that, yeah, there's some relationship, but these ball lightning is a very, very strange thing because the behavior, first of all, they can last so long, right? I mean, in materials, people are finding, for example, John Dash uh, was showing these filaments continue to grow for months. You know, like if you do an experiment and you put the components away, you know, after the experiment for months, you'll still find reactions happening. So that's the fifth state of matter. This weird stuff that's happening without any energy input. It shows there's a state inside this material or on the surface, right? So I think Savatamova also talked about this, and also when Uruzkwev and other people are finding that components continue to emit these microball lightning or microplasmoids, they continue to emit them maybe 1 month or 2 years later, right? Something is inside there that's doing it. So that's what has to be researched. The state of matter.
Ed, sorry, it's not an answer. It's a discussion about the question.
Okay.
Let's finalize this.
Okay, let's do it.
Discuss. Okay, thank you.
And Tol, do you remember the second question too?
Does he know that the second well-known scientist who used the word plasmoid is Pyotr Kapitsa, the Nobel laureate in Russia? And he was trying to recreate ball lightning using a microwave discharge. I said there is no palladium there, no electrodes. So all those MOTs, as they say, are being shoehorned in. There's no Lena, at least not on the electrodes. And then he started getting confused here. You know, he really wanted there to be a reaction, you know, and definitely to drag in Lenar, so to speak. That's what he wants, so to speak, but he doesn't have a clear understanding. I told him that Kapitsa actually observed transmutation where helium appeared from deuterium. So it's transmutation, but not quite. Well, basically, it's still a complete mess. Let's listen.
Totally, I
further.
understand. Thanks. Just to clarify, I want to say that the presentations, specifically Anatoly Klimov's second question, is actually broader and relates more to the second presentation than the first. Totally, thanks. Last question from Bob Grenier.
Ed, are you aware that I have all the original material from Matsumoto?
Yes, because you visited him, I know.
I have everything he ever did.
Wow, cool.
So I can improve all of your media.
Okay.
But I can answer both your question and Anatoly Klimov's, but I will do
that'd
that
be good.
discussion at the end.
All right. That sounds good.
Bob, your answer is your answer. Today Edward is main presentation.
Yeah. Okay, so this one is actually probably a lot more interesting to you. Okay, so here's Matsumoto's original tracks from the 1995. He called it ball lightning marks, micro ball lightning. This is Uruskarev's right on the right? And then this is a picture of ball lightning going through the window. Yeah, interesting. You can see there's a tail. So I'm in these slides. For some reason I'm interested in tails. What's causing this tail that makes it look like a comet? And is it because like comets are plasmoids too? You know, that's the question I have actually. So plasmoids are an interesting structure of matter and energy that's outside of quantum mechanics. There's no way you're going to, even though Lutz and others are trying to explain this by quantum mechanics, you can't. The reason you can't is because things are going on that quantum mechanics cannot explain, which is why there has to be a paradigm shift. So, okay, so here's a picture of these plasmoids that I'm trying to say that they're everywhere. They come out of volcanoes, and you find them in the sky, like you can find them inside of clouds. So there was an American researcher named Herbert Jones, I think, who talked about how he sees very, very big lights inside of clouds. And often, well, not often, but sometimes these big lights turn into tornadoes. So that's an example of atmospheric ball lightning and how it causes weather phenomena. Okay, so here it talks about big ball lightning comes from volcanoes, and Egon Bach wrote about this in the 1990s. I don't know what happened to him. I tried to find out, was he alive? This was back in 1990s. I wanted to write him, but I could never find him. So maybe he died. So, but he wrote a good book. It's called UFOs from the Volcanoes. So here is a Tom Warner video, one frame where he shows that ball lightning at the beginning of every lightning stroke, if you take a very, very slow motion video, you'll see a ball going through the sky. Before the lightning stroke, there's a ball. And the videos of Tom Warner show this. But I don't know why this area of physics isn't studied more. It's very interesting that lightning is created by ball lightning. And we don't understand that. So, okay. So you can see that in this frame, you start to see a tail, right? There's a ball moving across the sky, and then you start to see a tail following the ball. But actually, this is moving so fast, you can't see it happen. What you see happen is then after the ball lightning moves across the sky, then the whole trail of the ball lightning lights up. So then you have lightning. So that's so this is a picture of big ball lightning mark. There's a lot of these. Other ball lightning researchers, such as Otsuki, he was Japanese, and Ofuruton. There were two Japanese researchers who, I think Matsumoto knew them actually. So they found ring markings in the grass or, you know, someplace. And then to the right, there's these rings, and people would call those in England crop circles or something like that. But they look very similar to this, right? So this is by Matsumoto. So so it shows that what we're dealing with is everywhere. It's not just, you know, microscopic. It can be very big. So this is Ken Schilder's original tracks. On the left, you see what he called an EV chain, right? Then Matsumoto, if I remember correctly, made the next one, which shows that the chain somehow broke. And so it's really interesting, or that's how I interpret that. And the next one is by Matsumoto also. And it shows like the third one is from electrode tracks. Then I put these all together. You can see that, yeah, Matsumoto also found these long lines, right? And it shows that somehow the rings made that, right? So as if it's like a tornado going across the ground. And this is kind of similar to this one by Viau. I don't know how to say his name. He's French. Is similar to that one, that second one, right? Okay, so and then this one, what did I put? Okay, anyway, it's okay. So this is by Baranov. Yeah, I really like these pictures. They're so beautiful. They're so clear also, you know. And this is in comparison to what Matsumoto made on electrodes, right? And then here's some more by Ken Schilder's. I'm just showing different kinds of rings here. Savatomova, Ken Schilder's, Matsumoto. And then, yeah, so here, so the Savatomova, Ken Schilder's, and all that. And they're so interesting. There's so many shapes to this. It's like amazing, right? I don't know who made this one. Baranov, yeah. So I think all of you are familiar with this, right? I mean, you study his papers. This is by, what is this? Okay, what is this? I think, did Baranov make this? Maybe, yeah. Yeah, they leave deposits. So Matsumoto started to find all kinds of deposit marks, including, they're called hexagons. And that's interesting too. Why do they leave hexagons? So, and I'm trying to go fast. This is Ken Schilder's holes. So one for this fifth state of matter, they're so okay, amazing. One kind of, sometimes they can switch states. One state will make a hole, like just like that. This is a tunnel showed by Jim Egley. So it was in his, he wrote a book called Hungarian Ball Lightning Observations. So that's from that book. This one on the right is by, oh, is it Shoulders? No, it's by Svatomova. Yeah, and they're so powerful. This is metal. On the right, it's hard metal, and still is able to make kinds of grooves. I call them grooves or scratches or something like that. So, so yeah, Svatomova, Davao, and they make tunnels. So, okay, in Russia, a lot of people for some reason are only focusing on surface markings, but they also make tunnel markings. They they can go under the surface and then they make tunnels, and this is why sometimes when I read Russian papers, I think they're not really understanding how different these are. It's not like a particle of some kind of dust is making this. Whatever is doing these kind of things can make a tunnel, and these tunnels can be very long under the surface of materials, right? Under metal, under glass. And so, yeah, so here's some markings by Priakin, where he talked about their effect on plants, right? And so some of these caterpillar marks are on glass, and some are on X-ray film for Priakin, and then here's okay, showed a long time ago, is that when one of these objects, microball lightning or a mycoplasmoid, contacts glass, somehow the glass, it seems like it melts, but it doesn't actually melt, because Ken Childress has always said he can never detect any heat. Somehow it turns the atoms into something like a superfluid, but it's not due to heat. And that's the other concept that when I read some Russian articles, they often say, well, they must have heated the material in some way, but it doesn't actually heat the material. It just makes it move. And, you know, it somehow turns the atoms into a different state. And then in this different state, like they start to move in very strange ways like that. So, okay, so that, and yeah, so he called them EVs. So, okay, and this is on, this is actually a very similar thing. So see that, and then see how Mars, right? On Mars, you can find these objects also. This kinds of craters and that kind of, it looks very similar to what Ken Shoulders made, right? So yeah, these are huge. These domes or whatever they are like in these craters are kilometers wide or 100 kilometers wide, something like that. So they take them from the spacecraft pictures, you know. And okay, so this is a picture of, it was found over Tijuana. This big ring formation was over Tijuana. So someone took a picture of this. And see how it's very similar to the ring cluster, the beat chain of Ken Shoulders there on this side. So I think it's pretty amazing how they act. I really don't understand. Actually, I do. Maybe I understand. A long time ago, I met Ken Shoulders, and he was trying to explain when the plasmoid ring hits the surface, it'll leave a ring track similar to some of these kind of you don't see individual pits, which is something like that, you know, like what Matsumoto showed. You know, you don't see individual pits there. And this, he was talking about Bostic's experiments. They didn't find individual pits. He was the first to show, because he said, if you read his book, he started to fine tune his equipment. So he left behind all the other cloud of, I guess it's electrons or cloud of plasma, and these little inner pits, which he calls, so in his, the plasmoid is kind of the whole object, but inside of a plasmoid you have EVs. So that's what he would talk about it. So the EV, those are EV pit marks, right, on the right. So those I call them microball lightning pit marks, because I identify the anomalous object as the material in the fifth state. The cloud of other material could be a plasma that surrounds the thing, right? And that's why you don't see individual. Sometimes when it's a ball lightning, what you just see is just ball. You don't see a configuration of objects in a circle, right, or something, or in a sphere. So then so here's what did I write here? Oh yeah, and then John Dash. So I started in the 1990s, started thinking, how long can this material last? Is it just for a few seconds or a few minutes? When I started to understand about tornadoes, that they can last, you know, a long time, like an hour or 2 hours, like that, hour and a half or something. Then I said, how long can the material last? So, and for the first time in the early 1990s, I thought, when I read Ken Shoulders' paper in 1995 in Fusion Technology, where he showed pictures like this. Yeah, he started talking about fibers and things like this growing, right? So let's grow over a period of and these fibers change shape, and they were just sitting there by themselves. And then I said, oh, that's the first evidence I saw that there's an actual material that continues to grow by themselves. And then there's isotopic change, right? He doesn't record that there's elemental change, but he does try to show there's isotopic change, if I remember correctly. And this is by these more crystal formations, or not crystals, and by in 2013. And okay, is a picture of a kind of a. It would look more like a ball if he hadn't pictured this. You can imagine there could be a cloud surrounding this, and then it would be look like a sphere. But Bogdanovich was able to show the individual micro. And the one on the left is also by Bogdanovich, right? And that one was moving very slowly on the surface for a few millimeters every second, he said. This is also Bogdanovich, and this is starting to show that there's two black state. So in Ken Childers' experiments and also in natural ball lightning, you can find that they change shape. Change state. So the state of matter, the fifth state of matter is in itself has states, the black state and the white state. And individual ball lightning can change back and forth between these states. And when the state is white, then they're very active, and they can cause holes and tunnels and electrical shocks, and they can explode. But when the state is dark, in the black state, then they're very, very difficult to detect, and they can go through materials, glass or any other material, as if they, without any interaction with the material, or very, very little interaction. So so here's the states. You can see the ring that the black ring is backlit by the bright light behind it, right? So that's why you can see a ring there. You can see sort of the outline of the object, but you can't actually see the object. The object is black, right? Because it's in the black state. But I believe that these black objects can change state to a white state, and then they can change back. So Egon Bach wrote a book where he actually showed pictures of very, very big ball lightning that were in a chain around a volcano. How they, for a while, they're white, then they turn dark, then they white, then they turn dark. I think that's state shift. And the other idea about this ball lightning is how they have such sharp turns with any acceleration normal in the way we under and acceleration. An object has to slow down if it's going to make a turn. Like, for example, a plane can't just go one direction and then take a sharp turn to the right. It's impossible. There has to be a curvature, or there has to be a deceleration. Like a helicopter maybe stop and then turn 100. And his also talked about how these don't show any acceleration or deceleration when they move, and he was trying to use this frame as his evidence. And there's other pictures like. So he says this because you can see they're turning, but there's no brightening at the corners. I know this because I talked to him. I talked to him several times. So he showed me this picture and he talked about it, I think. Or anyway, he talked about these kinds of pictures. And it's the same UFOs or a big ball lightning. You'll see people say they make such sharp and very fast turns, and it seems impossible with no curvature in the turn. Okay, so so these are like, yeah, not really well understood things, but and then they have physical effects. So I liked this paper by Priakin and also by Rutsgrev because they actually showed physical evidence, and I thought it was a good paper. So I wrote a paper about this, and I think I put the link. Yeah, there it is, Infinite Energy. And you can go to the website, infiniteenergy.com, and look up the 2024 article in, I think, March or February or March. And it just talk about if you're doing experiments, please be careful about the effects. And so, okay, thank you. So it's finished. Now you can ask if you want.
Okay. Thank you, Edward. And friends, please, your questions for Edward. Please raise your hands if anyone wants to ask questions. Questions in English. You can speak in Russian afterwards. I'll also ask a question. Eduardo, Ed, you, as I understood you, you talked that Linear's lightning is a movement of ball lightning through the atmosphere. Is it right or not? Once again, linear lightning is a movement of ball lightning. Is it right or not?
Right. It's a path. It's okay. So yeah, actually, it was Ken Shoulders who I think introduced this. I didn't realize it.
First
I
of all,
understood.
yes or no? After
Yes,
that
yes,
explanation.
yes, basically, yeah, yes, yeah.
Okay, thank you.
Friends, my question was whether I understood correctly about the presentation that according to Edward Lewis, linear lightning is a manifestation of such a tricky movement of ball lightning as an example of such a cunning movement of ball lightning. I asked if that was the case, and he replied, yes, that's his point of view. Okay, then I have no more questions, and two people. Sunny, Yevgeny, I see that you raised your hand. Don't worry, I'll give you a chance to speak. Tolya, please, your question. Friends, let's ask the question in English and then comment in Russian about what you wanted to ask and what you think he answered. Tolya, go ahead.
Edward, you told us about fifth meta state, and definition of this name is absent in your presentation. What do you think about exact, correct definition of this name, plasmoid? For example, plasma definition plasma is the mixture of the charged particles. It's well-known definition. And what means plasmoid according to your presentation, according to your opinion?
Yeah, a plasmoid in the fifth state. You know, there's different kinds of plasmoids. I mean, like if you read books about ball lightning, there's other types of plasma that are in nature that you can see that retain their shape, right? So it's a plasmoid, but the fifth state of plasmoid, like the plasmoids in the fifth state are some kind of structure of electricity, and somehow the electricity retains their shape, and inside of this, there may, as far as I know, there may be ions. Like there may be C.I.C, because nobody can really do any experimental research. We don't know what's inside of a ball lightning. I mean, we assume, okay, if atoms are coming at us, and then you can assume like the way that some theorists such as Geithner and Lutz Geithner and Mashinsky and others are saying, inside of say,
Edward,
they say that.
Do you have a short definition? Oh, you don't have at that moment.
There's no. Yeah, okay, some kind of it's matter. My basic definition is that's less.
Sorry, very big, very worst connection at that moment. Connection is very bad.
Yeah,
at that
my
continue, please. To several last sentences of your answer. Continue. Repeat, please.
Yes.
No, bad connection that moment.
So a plasmoid that's in the fifth state of matter is basically electricity, somehow bound together, somehow that doesn't dissipate, and then maybe it has ions inside it, but there's no experimental evidence that it has ions in it. We just assume they have ions, and I actually don't assume that myself. If you believe in quantum mechanics, you're going to have to assume that, yeah, there's ions inside it, inside of this kind of matter. But yeah, there's somehow, I don't know, it's another state of material, I guess. Was that so? I say that the atoms themselves are in a different state. I conceptualize it as atoms in a different state. So just like, okay, so an atom in solid acts one way, an atom when it's in a gas, different way. So the same material acts very in different states, right? The atom
Ed,
and then
sorry.
yeah.
No short definition. You have that moment. Толь,
Yeah, no short definition.
пожалуйста, no short definition.
Yeah,
Толь,
no.
пожалуйста,
Yeah.
Let's stop your explanation. Толь, please comment on your question in Russian and then answer it.
He asked Edward if there is a definition of the fifth state of matter, which he called plasmoid. Well, he said, as we are taught, plasma is a mixture of charged particles in space. Well, he started to get confused, and the conclusion is that now there is no clear definition. Well, he thinks that it is electricity. And then particles also play an important role, a series of size, in short.
Thank you, Tolya. Are there any more questions? No, thank you. Thank you. Second answer from Bob Grenier. Bob.
The first question I think that Anatoly had was, what is the difference between Kapitsa's ball lightning and the micro ball lightning of, say, Ken Shoulders and Dr. Takaaki Matsumoto? I would argue they're largely the same, except one, in the case of Kapitsa, is typically, or in our ultra experiments, is due to resonance. And within resonance, according to Kapitsa's 1950s paper, you get a reflection of the microwave, or in our case, in ultra, the sound wave. And on the antinode, as per Kapitsa, you get a transverse. He says it's parallel with the ground, but we see transverse in our ultra experiments. And around that, you get turbulence. In the case of Kapitsa's ball lightning production, the electromagnetic waves cause ionization. In the case of our ultra experiment, you already have charge separation in the polar molecules, and then they get charge separated when they interact with the aluminium foil. So in both cases, in Kapitsa's, in our sound experiments in water cavitation, it's standing waves or phase conjugated waves, and you get the material, the electrodynamics produced transverse to that. So it's charge separation and shear. In the case of Bostic, he used a 10,000 amp pulse, and it produces a plasma loop which has magnetic reconnection, and then he fires a minimum of these two. When this happens, the plasma is undergoing extreme hydrodynamic shear colloidally. So it's the same thing going on, it's just going straight to the structure. And then they form tores of tores. So the same thing is going on from a resonance sense in our ultrasound experiments and in microwave experiments. So they produce the same thing. So that is basically charge separation and extreme hydrodynamic shear leads to these formations. The separate question that was presented was about how it forms hexagons. Well, in our experimentation, when you have the ball lightning, and so this is a quantum coherent condensate of Bose-Einstein condensate of atoms, and you can see the regular clustered array. but it's expressing as a hexagon. When you look at Bostic and Nardi's work from 1980s, you can see these multiple ring traces, but if you look inside the traces, they got substructures. They've either got rings that are orthogonal to the main ring or these bulbous areas. Well, we observe this with ball lightning strikes on our fused quartz, and you can see a 6-order structure here, a 4-order structure here, but in this case, you can see these are these kind of round blobs. This is what happens when you just get a strike mark. But when you actually get them manifest into solid objects, they then present themselves in crystal structures because they have to become normal atoms. And this here is a split structure, which is observed by Matsumoto here, this split structure that was referred to by Ed. And you can see this is a segment of that, and I can go into slightly more detail on that here. This is from the archive that we're working on, and this is a different focal depth, and you can see that the split structure is made of substructures. Moreover, when these ring structures break up, here was a ring structure breaking up, so the ring is here, and it has 3 things orbiting around each other, and then one of the 3 things breaks up, and then you have 2 things orbiting around each other.
Can you show that? Can you show that, Bob?
Yeah, so he describes that in his work, but not in his book, as a ring structure that is breaking up here.
Okay, all right.
Okay, and
Yeah.
if you actually go to my recent presentation to the ICMNS group, I can show you here where this is the image that we just looked at, where you see the ring structure breaking up. And here is where we see a coherent matter ball lightning structure breaking up. And so you can see this, but what you're seeing is persistence of vision in the camera trail.
But we don't see it. You haven't put it up.
You don't see it?
Yeah, can you put it up on the screen?
Oh, no, it's on the shared video. Can you see my shared video?
Okay, I see you. I don't see any pictures.
Can anyone see my shared video?
Yes, you can.
Okay, so I don't know why you can't see it, Ed, but it will be on the recording and I can send you these slides later. But essentially, we've got a plasma reactor and we've got a number of traces. And I'm comparing the trace observed by Matsumoto in, I think it was August 1992. It's published in Fusion Technology. And our traces produced in plasma in the reactor. And what you're witnessing is 2 structures that appear to be orbiting around each other. And you're seeing the persistence of vision of the trail as far as the camera is concerned. And when we combine these together, you get the full length of the trace. And this is actually 1, 2, 3, 4/60th of a second parts of the trace. In this particular case, this is a frozen coherent matter wave beam that is collapsed into a diamond braided structure. This is in a plasma reactor in Holland. This is in a plasma reactor in Canada, and there are 1, 2, 3, 4 segments here of multiple structures orbiting around each other. This is in the Dr. Roish and Amaza cavitator. So what Matsumoto is seeing here and what we are observing here, we see the ball lightning forming and then we see it breaking up. And a more extreme form of that is what you see here, where you see the structure that was in the material that persists for a long time and blowing up. And we witnessed this in cavitated fuel from Dr. Suhas Ralkar in his fuel container appear over a period of time. And so the comparison between Matsumoto's work here and this is very, very striking indeed. So to go back to the broken up structures here, this broken ring trace here is because this is made of substructures, and when the substructures fail, they can open up. And this is an example here showing a full ring that hasn't broken up, and this is showing part of a ring that would have had 48 subsections.
Well,
and here
Bob,
is another.
Bob, could you share that? I mean, I don't think you actually have shared it because we don't see anything.
I think people can see it, but I don't know why you can't see it. I think you're in the browser version rather than the downloaded.
Oh no, I'm actually in the share version. Why am I?
Maybe
Valerie,
it's
can you see his pictures? Because I don't see. I just see Bob, and I see no pictures.
maybe it's because you came in afterwards. So I'll stop sharing
Oh,
and start sharing again.
all right.
Try that.
Yeah, that might work.
And you are also sharing something on your screen, so that might be your problem.
Okay. Yeah, maybe I should. I'm
If you
trying not to share.
unshare your thing, you'll see what I'm showing everyone.
Okay. All right. Wait a minute. Oh, I see that now. Okay.
Right. So just for Ed's benefit, what I'm showing here is Matsumoto's ring trace, where the ring here has partially broken up into three substructures. One substructure here leaves, and it leaves two substructures coming down here and ending here. And
That's
I'm showing,
interesting.
and
Yeah,
I'm
those
showing
are.
here
Yeah.
in our plasma reactor that we have a ball lightning forms here on the video. You see it. Then it fails and it shoots out two orbiting structures that are coming out. And if I join those 4 60th of a second frames together, we end up with a structure that is functionally equivalent to what Matsumoto observed. Moreover, on this particular image, if we go to this presentation, you can see other examples. This is like the work of Anatoly Klimov, where we have a ball lightning that's broken down the bottom here. Okay, and in fact, the ball lightning looks like this. We're able to look through the ball and see into the ball that it's made of substructures, and that those substructures have substructures within them. So this is a wheel within a wheel within a wheel, making the overall ball. And that is the basis of the electrodynamic structure. It's all magnetohydrodynamics. And when these things break up, they let out subquanta. So the track that you observed earlier, borrowing through the material, is effectively one of these structures, where you see mostly on one side the punch hole. The other thing that you said was about things moving around each other. This is 3 frames, and they don't care about the cathode and the cathode is the bottom, the top is the anode. They only care about each other when they're in event horizon. So what these structures have is a non-radiating boundary, which is the spherical part of the ball lightning. And it all comes from an extension of Yakov Zeldovich's work with the work of our good friend and sadly departed Vladimirovich Dubovik. When you get these electrodynamic structures interacting, they produce a non-radiating boundary, which is your boundary of ball lightning. Now, what Matsumoto showed in his book, but it wasn't clear enough, but we can now reveal, is he observed these tores of tores. And in fact, some of his most incredible iterations of showing this, I can show you here. And so this is exactly a replication of what what Bostic saw. And in this case, he actually has 48 subtores. And in the subtores, you have multiple tores within the tor within the tor. So we've got substructures here. That makes one substructure that makes the overall structure. A wheel within a wheel within a wheel.
Okay, Bob, could I ask a question?
What's that?
Okay, where did Matsumoto ever publish any of this?
This is not published. This came out because he told, when I met him before he died, he told Sho, my translator in Japan, that when Bob gets the materials, he's going to find some very, very interesting things in there. He
never published this.
He never published it because I don't think he realized the significance. He did publish this, but it's not high enough quality on the book, even the remastered book, to be able to observe it. But he does discuss it.
Right,
So
right, yeah.
This is actually in his book. These traces here, these ring traces with substructures within them. Okay?
Yeah, those are very, very good pictures. Yeah.
We're going to be republishing this in full color with remastered images from the original negatives. And if you look here, I've got 142 kilograms of the original materials. And it's spectacular. So, like, for instance, you were saying here about you don't see these traces. Well, here you see an exploded, where is it? Here you see an exploded ball lightning with the substructures coming out. Okay. And when you look at this under the imagery, this is actually a hemispherical pit. And then you see these two structures coming out, and they all start to orbit around each other. And then sometimes they break up and split up and go away.
Okay.
But he observed all of this. And also,
Yeah, that's a very important, that's extremely important, actually.
and,
Yeah.
and here you can see the ball lightning, that's the sphere, and here the orbiting structures around it as they are interacting with the material. And I showed how this was functionally equivalent. And fortunately, I was able to share independent replication of nearly everything he observed before he died, when I visited him in Japan last year. So it was very fortunate I was able to see him before he passed and be able to show that his work was independently replicated without anyone actually knowing they were replicating his work, if you know what I mean. So yeah, so I just want to answer all the questions that were asked and so the confusion. So the tail is three things. It's a persistence of vision and ejection of captured or synthesized material. So
Right.
I can show you here. This is in Binjuan Huang's system. So here is something that's being ejected from the magnetic core. And this is 2 titanium discs, largely, and a mostly carbon ejection. Carbon is one of the most products that's observed being ejected. So this is 2 titanium discs, titanium rich. You can see here it's 11.3% by weight. Their structures are hollow, as identified by S.V. Adamenko. This is in Huang and my analysis. There's titanium structures within, or toroidal structures within the magnetic core. And when this particular magnetic core broke up, like a horse chestnut, it has toroidal structures within it that come into the core. And you see that this is rich in titanium. It's 23% here. And this is the fusion of CO2. The structures are toroidal, but they can become almost spherical in terms of their non-radiating boundary. This is axial hypertoroidal moment. You call it supertoroidal in Russia. I call it fractal toroidal because it makes more sense to me. And this is what we got out of Binjuan Huang's system. Yin with a yang, yin, and the yang with a yang. And these two structures are bound. Sometimes they can link together, but inside they have subtors. So these are the things that you see flying out, and they can orbit around each other. Anatoly Klimov has seen this in his plasmatron devices. And when they fail, they eject the synthesized or captured material. And this could be part of the trails that they leave. You see in this instance here, we have one of these large structures. These are the same size at 20 microns as identified by Ken Shoulders. This is the non-radiating boundary of the outer structure. And you can see all of this synthesized material, which is typically stellar synthesis. What I like about this experiment by Binjuan Huang is on the copper oxide substrate, it gives a high contrast between stuff that's synthesized and coming out of the structure and stuff that is in the background. Here you can see a structure is completely broken up, but before it did, the substructures inside have braided the synthesized material, which is rich in titanium and carbon bands. In this instance, you see where the material is sucked in to the magnetohydrodynamic structure, and it's so powerful that it can rip copper out of the solid metal. And it does this, I believe, by weakening the electrodynamics of the metal bond. And so the metal falls apart and it's not melting. This is one that's spewing out material. So you can see here, this is the magnetohydrodynamics at play. It's exactly and precisely magnetohydrodynamics. And when you look at the broken substructures, and I haven't changed the scale here, this is 20 microns. This is just moving the microscope. I can overlay here the same structures, 20 microscopes, microns. This is the substructures inside. And you can see here the substructures inside. And this is folding around on itself. This is folding around on itself. And so here is one of the large structures, and it's consuming the copper as it's crashing into the structure. In this case, on the right, you can see it spewing out the synthesized stellar synthesis of material in a vortical beam coming out. So that, I believe, answers the tail. Now you get tores and spheres because you are seeing substructures, or you're not seeing the full non.
Bob, very interesting presentation. Thank you very much. It's your collection is comprehensive.
I would
Так,
like to say
это самое.
thank you one to Anatoly, because I couldn't have understood some stuff without Anatoly's work. And I have to say thank you to Ed Lewis, particularly for helping Matsumoto on his journey to understand that this was ball lightning. It was very important, and he recognized that you were a significant part of his journey.
Okay,
Thank you.
Thank you. Значит, друзья, появился Эдвард Льюис. Эд,
Yeah.
we understood that you lost electricity on your computer.
Right. I
It's
forgot
very
to put in
strange. You should prepare carefully to your presentation, but no preparation. You worked on mobile. I see mobile mode without connection to the to the external electrical
Right.
circuit, as I understand. Unfortunately, a lot of strange situation existing in your presentation, in your webinar, in your conference presentation, and now also. Now we start a study of discussion. Discussion will be in Russian, not in English, in Russian, and
Right.
we don't need in your comment immediately now, but you will send me your comments when you will see the video record, and
Okay.
and you will switch on mode of translation of video record, and after that you may send me back your response of this
Bob, is there
discussion.
a way, is there any way right now to put in a translation into English?
If you could, it was, but discussion will be in Russian. Let's start the discussion in Russian about what we heard today. I tried to explain to Bob that he can look at it and translate later, not Bob, but Ed. First, let's have Andrei Chestolinov say something. Andrei, please.
Yes, good day, everyone. I just have a brief comment. It was delightful to hear how two Americans met and connected at a Russian seminar on ball lightning and cold fusion. I wanted to say that Edward definitely came to the right place with our seminar, because in our community, I think the vast majority are convinced that there is some connection between ball lightning and the strange radiation cold fusion accordingly. And by the way, it was really nice that Edward made the slides in Russian. Just a huge thank you to him for that. So I must say that as it seemed to me, Edward is mostly trying to grasp something intuitively in a figurative way, and apparently, as we see it, he is on the right track. But what comes next? We also agree with him that there is some connection between strange radiation and ball lightning. But what is the next step? That step, I practically did not see this next step with Edward. There should be some theory following this. And what Edward is proposing are just some words about how ordinary matter can transform into some unknown form. But what's next is there needs to be some kind of connection, or at least an explanation of what this matter is, how it interacts with regular substances, and so on. How does it enter this state? As far as I understand, Edward doesn't have any of this, and this is actually the key point. And most importantly, how all this aligns with modern physics. Well, that was my comment. In principle, we're thinking along the same lines. It's possible that, like Edward, almost every second person among us has their own theory on this matter. If Edward is interested, he can get acquainted with all of our theories. That's it. Thank you.
Thank you, Andrei. By the way, thanks to Bob Grenier, who included his presentation, and we can see English subtitles for what we are saying in Russian. Thank you, Bob Grenier. Thank you, Andrei. Thank you. Tol, please, your presentation.
Well, I would like to thank Lewis as well for, thanks to Edward for preparing such a overview report here. And well, all the ball lightning researchers know exactly who is involved in, at least studying the physics of ball lightning from different angles. Lewis is one of the few who is frequently cited and published in foreign press. In this regard, I, like Chistolinov, also expected that there would be progress, at least in terms of observations. So there will be progress towards, at least. So here's the thing, observables. What he told us is, at a basic level, organizing the material, and that's an important step. That's where science begins. Then what Andrei suggests is like moving on to zoology, so to speak. Let's come up with some hypotheses. Unfortunately, we haven't heard a single hypothesis yet from Edward, which is unfortunate. Here I agree with Andrei, but hypotheses are still not a theory. Theory is always tested by experiment, and the theoretical model already anticipates extension in the planning of experiments to confirm certain qualities of these unidentified objects which may exist. Well, if someone liked calling it a plasmoid, it means that now in scientific literature, the term plasmoid carries quite a specific meaning, which therefore still magnetic forces here or the forces that bind together, objects, meaning forces, that is, physical forces, can be not only Lorentz forces, but also, for instance, chemical forces like surface tension. One of the models of ball lightning involved the use of surface tension forces. So, like just such an object, or such models were considered in the physics of the ball lightning. At least ball lightning is real. Well, it's a pity that Nikitin left. At least we're trying to build a bridge between what we know. Well, we named it plasma, all right, but these compact formations with structures are not plasma, definitely not plasma. We need to introduce a new definition. Perhaps it is not the fifth state of matter. Well, maybe it is plasma, because plasma has many gradations, expressed, not expressed, ideal, not ideal, structured, unstructured. There are many types of plasma. Well, if nothing else fits at all, then let's just make something up like plasmoid, so to speak. Anyway, they've been trying to create ball lightning for 100 years now, and no one has truly succeeded. But there are many connections being explored, like those Yuri Nikolaevich Bazhutov tried to make, indicating a link with new high-energy bombs, nuclear reactions, which are currently tentatively called Lenore, are like plasmoids. They might not actually be related to nuclear reactions. One thing that is important is the energy reserve, so to speak, of ball lightning. Such calorimetric measurements of natural ball lightning have been made by more than one party. In general botany, which Edward spoke about, such experiments mean a lot and Nikitin conducted an analysis and a statistical review of these observations, revealing that the maximum energy reserve of ball lightning is approximately 10 to the ninth, which is 1 gigajoule. 10 to the ninth joules, well, if you divide it by the assumed mass of a ball lightning, the size is known. Levitating, it's considered to be about as dense as air. So in terms of density, well, almost like air. So it is not really what Bishkov says about a cannonball core. So it's not a ton. So it turns out that the energy content in such a lightning is approximately kiloelectron volts per particle. We observe roughly the same kiloelectron volts in Leonard physics, so to speak. No one else really, well, except a few, so to speak. In any case, the best measurements of specific power in Leonard are, well, tens of billions. Well, it approaches around 100 keV per hydrogen atom or metal atom. This really seems to indicate that energetically, the two objects are in fact quite similar to each other, are very similar to each other. When ball lightning fades away, well, I will muster the courage and share what I know about ball lightning for posterity. It's often observed that there remains a pile or pyramid on this earth, ashes that for some reason are not scattered by the wind. They remain together. Well, analyses like these were conducted by Voronezh University, St. Petersburg University, and Tomsk University. It turns out that the elemental composition very similar to what we have in the transmutation of elements in reactors when people study cold nuclear reactions. If you look at the experiments with Leonard, you will notice that almost all groups are starting to have matching lists of these elements. All the key elements are practically the same. Of course, it depends on the electrodes, the liquid, the gas. There are specifics, but typically similar elements are formed there, which are present in everyone's list. It is sufficient to say that sodium is always present, potassium is always present, and there is plenty of carbon, and so on and so on. In this regard, the chemical composition of the ash left after ball lightning also resembles that of Estland. Therefore, this chain of analogies can be explored further. And Yuri Nikolaevich Bajutov. So I have been debating for a while whether we should include ball lightning in our conference, our seminar, or should we treat them as parallel fields that might converge at some point in the future. This is probably the only community, our community, where we still haven't thrown out the fence, the physics of ball lightning. And just like with Leonard, I agree with Edward. Let's keep the plasmoid theory of ball lightning as it is for now, even though it exists. It does not reveal anything to us in terms of a physical model. That is my brief comment and his report. Thank you very much.
Thank you, Anatoly Ivanovich. Your brief comment still took about 10 minutes. Thanks. It was very much to the point. Thank you. Evgeny Ivanovich, please, Egorov.
I disagree with Anatoly Ivanovich that we are unable to generate long-lived plasmoids. In other words, long-lived ball lightning. The experiment by Vachaev and Ivanov is an example. Their plasmoid lasted for more than 2 days. So how to maintain it? Well, it's clear to me. The approach using the vector potential of the magnetic electric field and the primary non-linear, I emphasize non-linear interaction, provides, in my opinion, very fruitful opportunities for experimental reproducing these experiments on a broad scale, so to speak. Thank you. Yevgeny, I need a moment. Well, it's still not entirely clear whether the speaker, I mean Edward Lewis, heard the question
He
about
heard
reaching
your
Abanoff.
question, Evgeny.
Does he know how they work?
He heard it, but he could not answer it. Thank you, Evgeny Ivanovich. Alexei Cherepanov, please, your turn.
I'll keep it brief. Thank you to Andrei Chestolinov for saying everything I wanted to. And Anatoly Ivanovich added to everything Andrei said. I just want to add my little bit, like a small drop, that the nature of ball lightning and plasmoids and everything related to discharges and so on, from my point of view, is based, well, in the idea I am promoting. It is about the photon wave and photon mass. And separately, everything I wanted to tell Edward, I posted in the chat comments, which he can download via the links to know my opinion. That's all.
Yes, I will send the chat around. Alexei, thank you for your presentation.
Friends, is there anyone else here? I do not see any hands. Let me say a few words. First of all, a big thank you to Edward Lewis for trying to improve our understanding of his presentation. He put a lot of effort into it, so let's thank him for all that. Some people have already mentioned it today. Overall, thank him for the presentation, because I personally heard a few things that were new to me. Well, as I recall about these ball lightning tales, I remember that our main speakers on ball lightning, I mean, there are several people here, probably 3 people, mentioned something about it, but not very actively. But Edward spoke very actively about the tales. And this is quite new to me. That is very, basically, it turned out to be a constant component of the ball lightning. I remember Chistolinov provided a lengthy list of properties of the ball lightning, and I did not see those mentioned details there. I do not remember, maybe I was not paying much attention back then, so this is new to me. His idea that the ball lightning and the linear lightning are the same hypothesis by Edward Lewis, and it seems a bit implausible to me. There might be a more standard explanation that seems more logical to me. Ball lightning simply follows linear lightning, which is mainly recognized as ball lightning by enthusiasts. So this seems like a more logical version to me, because physics allows for different scenarios. And maybe sometimes what was discussed actually happens. Edward, linear lightning at times, or maybe can be a manifestation of very fast movement of a spherical wave. Perhaps that could be the case too. Now, about plasmoids. Look, regarding the term, first, I want to remind you that the term plasmoids actually came from astrophysics. They call a certain part a plasmoid, plasma around the Earth, which is enclosed by a closed magnetic loop. It's like a magnetic cocoon. And it's like, a magnetic bag, if you will, because particles, according to these standard magnetohydrodynamic theories, they do not necessarily pass through magnetic lines. They think it's much easier to move along the field line. If you create a magnetic container, then the plasma inside will exist there without scattering. That is where the idea of these plasmoids comes from. This idea goes back to astronomers. The idea of the thermonuclear reaction of Sakharov, of this magnetic bottle, and this idea is rightly cited here, seems to have somehow been transformed by Kapitsa into laboratory conditions from space. It's the fourth state of matter, a mix of electrons, ions, and non-ionized atoms with a net zero charge and an electromagnetic field. So it has four components. And the electromagnetic field is an important part. Reiser has a definition of plasma that Klimov talked about. According to Reiser's book on plasma, plasma is a mixture of electrons, ions, and non-ionized atoms. Rukadze made significant contributions to this definition and said that plasma is the fourth state of matter, a mixture of electrons, ions, and non-ionized atoms with a zero net charge and an electromagnetic field. This makes four components. The fourth state of matter has four components. The electromagnetic field is a critical component. The density of the electromagnetic field.
Now, the electromagnetic field is a very important component. This has been mentioned today, and I fully support this idea. I think that ball lightning and ours, the processes we study are primarily distinguished by the density of electromagnetic energy, which is responsible for the process we refer to as linear, which they call
referred to as unknown radiation, which you mostly call strange radiation. It's an energy density responsible for this process. Klimov calls it linear, meaning 1 kilovolt in electrons per particle, but I would suggest a concept of energy which could also be in kilovolts in electrons per particle. I think it's more important, and maybe I'll write something separately on this topic because I think it's very important. It's important because energy can result without relying on scientific concepts like the electron or proton, which we are used to considering. I think this is very important, and energy flow can become relevant even without such apparent outcomes if monitored using electrical energy. I think this is very important. And the flow of energy can be realized even without such known results if there were invented supervision with the help of electrical energy.
But still, we did not see or hear any theories here. I call this approach observational physics. This is not the physics of formulas and theories, but rather the physics of observing phenomena. And perhaps at this stage, we are at this kind of observation, this kind of observational physics is extremely important. It helps us understand. So, what exactly are we doing? That's why I wouldn't dismiss this approach. I find it quite useful. We need theories, we need experiments, but we also need observational physics.
And I recall that people who studied ball lightning realized this a long time ago. Such simple approaches became clear to the best people in plasma physics like Kadomtsev, Smirnov, and others. Our best plasma physicists tried to achieve something, but nothing worked out. And it became clear that maybe observatory physics too. Physics is important, and it will help us move forward for me, and you did it. I saw that Faraday was working on this. Once a theory emerges, people start studying physics. Thank you to Cherepanov for the suggestion. It should not be dismissed. I think it is very important. Thank you, Edward. We have such people. Let me remind you that our research on ball lightning is primarily based on observatory physics, in my opinion. And the theories they are developing, in my opinion, are still very incomplete. One more thing. I've finished this part, and I think there's something else that's very important. The dark plasmoids that Edward Lewis talked about today. I have to admit, this is the first time I've heard about them. By the way, thanks to Edward for mentioning several Russian researchers who were involved in recording these phenomena related to tracks. And in particular, he mentioned my close colleague, Dmitry Baranov, who once published some truly interesting photographs and tracks he recorded, particularly on the alpha particle detector, which were very intriguing. It's a very well polished piece of gold, coated in gold, and all of it was marked with various tracks, some of which Edward Lewis showed us today. These black plasmoids are new to me. From what I understand from the presentation, black plasmoids occur when light does not pass through a certain part of space. By the way, we were among the first to discover, and I think it was our laboratory with Baranov, the Alice laboratory. We found that regular X-ray radiation somehow passes poorly because in the lab where experiments are actively conducted, many people later confirm this. Some people even forget to mention or are not even aware. I would like to remind or rather say that I think these dark plasmoids, or more accurately, black plasmoids. Black is an English word, black. Just specifically what I understand by black plasmoids is that they absorb radiation. So if we say that black means absorbing, it is a good word for these things. Objects in space that absorb not only light, but I believe that if they were measured in the X-ray spectrum, there would also be absorption there. I want to remind you that in our laboratory, on our list of accomplishments, we introduced the idea of dark hydrogen. It's not black, but dark hydrogen. In English, it's not black, but dark, and not heavy, as some say, just dark hydrogen. This idea, I think it explains many of the phenomena that Edward Lewis reveals today. The observational phenomena that Edward Lewis discussed explain everything quite simply. Friends, once again, I want to thank Edward Lewis for his collection of observational phenomena related to ball lightning. Such observational phenomena linked to ball lightning, and I especially want to thank him for his analysis. We can talk about the potential public impact of our activities in physics, as we mentioned in the first part of his talk. Thank you for our conversation. And now your final words.
Ed, you may have a floor to say some final words on this webinar.
Okay, спасибо. Thank you very much for this time, and I really actually enjoyed it. I think Bob put the translation here so I could read what you were saying. Actually, the translation is terrible, but I can understand about 80% of what you were saying. So thank you very much. This is a good time.
That's all what you would like to say?
Yeah, I mean, I'd like, yeah, I hear your question and comments, but I think you said later I should try to write something and send it to you. Yeah, those are very, very good questions, and to answer those questions takes
Okay.
maybe 2 pages, 5 pages, I don't know.
Okay, Ed,